All right, so how do we actually identify a limit? I've tried to explain to you what a limit is. I've tried to explain what approaches means, but really, Mr. Ryan, we just want to get to an answer. We want to know what would the answer be in a particular situation. Okay, so here's the idea. Let's go back to one we've already seen. The limit as x approaches 6 from the left of the function x squared minus 3. Okay, so we want to know what the limit of this function is as x is approaching 6 from the left side. Okay, so here's what I'm going to do. I'm going to make a table of values here. I've got x values and I've got y values. I have not entered the y values yet. We're going to do that either together or you can pause the video and do it. And what we're doing first is I put in 4 x values here that are approaching 6 from the left side. So I have 5.9, 5.99, 5.999, and then 5.9999, which is even closer to 6 than this number, okay? So it is very clear that our x values are approaching 6 from the left side. So now what we would do is we would take each one of these numbers and we would plug them into x squared minus 3. So if I grab a calculator and I do 5.9 squared minus 3, I get 31.81. So I would put over here 31.81. And now what I want you to do is pause the video and see if you can calculate the next 3, okay? And then I'm going to do the exact same thing. All right, so I've filled in the rest of the values for the other 3 numbers. And so now what this question is asking is this. As x is approaching 6 from the left side, what is y approaching? What are we getting closer and closer to here, right? What output values are these getting closer and closer to? Well, I see 3181, then 3288. We jumped up by more than 1 here, right? But now we're going a little slower. 32988, then 329988. What is this really close to? Well, this number is really close to 33. So it looks to me like y is approaching 33 as x is approaching 6 from the left side. Therefore, the answer to this limit problem is 33. So as you can see, all we're really trying to find out is this, is what is the output value getting close to as the input value gets close to a particular number. That is the basic idea of a limit. And now what we're going to do is we're going to look at a couple more details of limits and solve a bunch of them. So there's another idea that I need to explain to you before we can really start identifying the limits of functions. That there are some situations where you are asked for the limit of a function as x approaches a certain value and there actually is no limit at all. Remember, the idea of a limit is that the output value is getting incrementally closer to one number. So if the output values are getting incrementally closer to one number, then you have a limit, and that number is the limit. But there are some situations where as x gets incrementally closer to one number, y, or the output value, the function, does not get incrementally closer to a number at all. In fact, in some situations, it either gets farther and farther away from numbers in bigger and bigger chunks, or it just doesn't get close to one particular number as x approaches a specific number. These are 4 different possibilities that you can see in a limit problem. In this case, so let's look at this one right here. This one is the limit as x is approaching. What's x approaching here? It looks like it's approaching 11, right? So 11.1, then 11.01, then 11.001. It's getting closer and closer to 11 from the positive side, right? So these numbers are getting smaller as they get closer to 11. So x is approaching 11. And look at here, y is approaching, we got 74.9, 74.99, 74.999. It looks like y is approaching 75. So in this particular case, as x is approaching 11 from the right, y is approaching 75, okay? So this has an answer, and the answer is 75. So that's a limit problem where the answer is 75. The answer is a number. But we have some situations when the output value is not approaching one specific number, we say that the limit does not exist or that the limit is non-existent. Now, there's a certain kind of non-existent limit that sometimes professors or teachers want you to answer in a specific way. Usually these are situations of infinity or negative infinity, okay? So let's look at this one here. We can see that x is going from negative 4.9 to negative 4.99 to negative 4.999. Looks like x is approaching negative 5 from the right side because these numbers are larger than negative 5. Well, as x is approaching negative 5, what is y approaching? Well, y is not approaching any number at all. We've got 1,000, then 100,000, then 10 million. The numbers, instead of getting closer to one number, are getting farther and farther and farther away from 0, right? In fact, it looks to me like these values are approaching infinity. They're just getting infinitely larger and larger and larger without getting closer to a number. So in this case, we would say that the limit does not exist. We usually put DNE for does not exist, okay? Or we can put the word non-existent. In this case, this limit does not exist. There is no limit. It's not getting closer and closer to a number. But in some cases, we could say that y is approaching infinity, and so we would just say getting closer to infinity. Now, there's arguments out there among math people. Math people say, by definition, infinity is not limited, therefore there is no limit. And then other math people will say, yes, but we can specifically say in what direction there is no limit, positive infinity. Very similarly here, we can see as x is approaching negative 8 from the left side, so x is approaching negative 8 from the left side. Well, what is y approaching? Y is not approaching any number. Negative 10,000, negative 100,000, negative 1,000,000. Y looks like it's approaching negative infinity, right? And therefore, we would say that this limit does not exist. Sorry about my terrible handwriting there. It's hard to write sideways. So whenever you have a situation where the outputs are approaching infinity or negative infinity, you can specifically say infinity or negative infinity, or you can also say that the limit does not exist or is non-existent. Now look at this situation here, where x is approaching, we've got 1.9, 1.99, 1.999. It looks to me like x is approaching 2 from the left side, right? And so, but now let's look at the output values here. So when we plug 1.9 in, the answer, the output is 4.5. When we plug in 1.99, the answer is 5.2. Okay, looks like the value got larger. When we put in 1.99, the answer is 3.8. Oh, wait a minute, it just got a lot smaller. So we started at 4.5, we went up by 0.7, then we went down by 1.4, right? It looks to me like x is not, or y is not approaching any particular value at all, okay? Or y is not. So as x approaches 2, y is not zeroing in on any single number. It's not getting closer and closer and closer to one number. It's just sort of jumping all over the place. When the output value is jumping all over the place as x approaches one particular value, again, because it's not approaching one single value, we will say that the limit does not exist or is non-existent. So here we would say does not exist. Okay? And now what we're going to do is we're going to go on to some segments where we actually solve real life limit problems.